Hi, very good morning all, and wish you all a happy new year. So, as you many of you know, this training is basically into advanced performance engineering. People who already have experience into performance testing for a minimum of 1 to some X number of years, or having experience with any of the performance testing tool, they can actually learn this course called Advanced Performance Engineering. The main agenda of this Advanced Performance Engineering is like we are going to explain you right from day one. Like we're going to talk about performance testing concepts, then we are going to explain about performance monitoring, especially on Windows Server. When you don't have any monitoring tool in place, when you have budget issues in your project, we are going to teach you what is that you have to monitor, how you have to monitor on Linux machines, on Windows machines, and also we're going to explain you about how we have to monitor and what are the metrics that you need to take into consideration when the test is executed. And again, coming to the Linux, right? If you have any application, if you take any application, right, it's going to install on n number of servers, be it web, app, DB servers, right? In a distributed environment where you have multiple web servers, application servers, and database servers, 80% of the servers, right, they sit on Linux, any flavor of Linux. When I talk about Linux, right, again in Linux, you have three different types of Linux types, which is Red Hat, then CentOS, and Ubuntu. If you are working on applications where you're doing testing on premise, or if you're trying to move applications from on-premise to moving on-premise application to cloud, or if you're working on containerized, Dockerized, where you have everything on Docker, Kubernetes, then if you have something like message queue, where you have RabbitMQ, or where you have Kafka, or if you're working with something like a service mesh, where you have so many microservices, API performance testing, many of them has to be tested on different flavors of Linux. So in that context, we are going to tell you how to capture the reports when you don't have APM tools on Windows servers, like Windows Server 2012, 2016, 2019, 2020, and different flavors of Linux. Most commonly used are Red Hat and CentOS. And also we are going to talk about Ubuntu, what makes a difference. And would like to reiterate some of the things that we are going to cover. The first section is completely talking about the performance testing concepts. Here, mainly what we are talking is we are talking about some of the performance testing key concepts. Even people who have experience in performance testing from many years, especially traditional performance testing, what we are mainly highlighting here is we are going to talk about how to transform your career from performance testing to performance engineering. The course, the way it is going to help you is if you have 10 years of experience into performance testing, how you can convert your experience into performance engineering with relevant experience, and how you have to prepare your resume projecting yourself that you have a very good exposure, knowledge, expertise levels in performance testing and engineering, mentioning that you worked as an individual contributor, team lead, or SME roles who have been involved in each and every individual phase of performance testing life cycle, engineering life cycle, APM tools, and also there are various things like monitoring web app DB servers, understanding the load balancers, client-side performance testing, using developer tools, and setting up the environment from the scratch. This is where we are going to talk about the challenges in setting up the environment, how to create a performance testing environment from the scratch, how you need to understand the architectural design phase, what is the role of code profiling, and when it comes to hardware sizing, right, how do you need to decide the size of web app DB servers if you want to test with example 10,000 users for 5 years. Okay, so all these things, how to analyze production traffic, what will be your typical roles and responsible for a performance engineer, how do you tune a career. So the reason why we have to spend some time in performance testing concepts for a while is because workload modeling, then capacity planning process, how to do efficient scaling, the importance of load balancers, load balancing mechanisms, load balancing algorithms, and the importance of understanding piece to piece from component level, from the architectural side, is the key of any performance testing assignment. A simple example could be a bad software design. Okay, a bad software design or a bad system design is a never-ending performance problem, which is going to degrade the performance no matter how many times you test. If you don't understand the architecture, you'll not be able to achieve the performance optimization with the numbers that are mentioned in the SLAs. Let's say you have to achieve some 300 milliseconds for a single API. If you don't understand how that API is communicating internally, externally with all the different components that you have inside your environment, it would be very hard for any performance engineer to find that performance degradation. So for that reason, we are spending some time on performance testing concepts, how to take some of the samples, how to do a math on workload modeling, how to do capacity planning, how to understand the breakdown between web app DB servers, what does a request contain, what does a response contain. So what is the role of network in performance engineering? What are all the things that you have to extensively monitor from the network side? So all these things will be crucial, and performance testing, some of the key concepts would become uh, essential, and they are prerequisites to go ahead with performance, advanced performance engineering concepts. So this is the section one I'm talking about, and section two, like I said, we are talking mainly on performance monitoring. Okay, a simple thing would be, most of the people doesn't, if you don't have a monitoring tool, let's say that you have a server installed on this machine. For example, I have a .NET application. Then .NET application is going to use IaaS server, which is an Internet Information Services server. You can clearly see here. You can see all these things available in this IaaS server, right? So if you don't have access to the IaaS server where your web application is deployed, okay, if you don't know where your application pools need to be set, if you can see, you can simply stop the server and you can simply start the server. If you don't have access to monitor your server, the activity on what's happening on your web application server during the downtime of your uh, IaaS server where your applications are deployed, you're getting HTTP 500 errors, you're getting server not found, you're getting page not found, you're getting internal server error. All these things are happening just because the server where your application is deployed has been down for a while. So if you don't have monitoring systems, if you don't have access to the servers, you'll not be able to find that. So in that context, what we are doing as part of our course is, we have a sample application for Java where we are deploying it on Apache Tomcat server, and we are connecting it to MySQL database. Okay, that is for Java applications. Whereas for .NET applications, we have an application. They're not dummy applications, they are live applications. They are, for .NET applications, we are deploying it on IaaS server, and we are connecting it to Microsoft SQL Server, where you have so much of data in it to show you what are all the problems from web server, what are all the problems from application server, and what are all the problems from database server. The main advantage of having this course is you can create your own environment in your laptop where you can create web server, app server, database server. You can deploy the application, and you can take heap dumps, thread dumps, and GC logs like the way you do in real time. That is how you are learning, involving in all the phases of performance testing life cycle, engineering life cycle, and that is how you are getting some hands-on experience. Okay, simple example would be, you have an application pool. If you want to go to the application, some of the application pool, if you want to do some settings on an application pool, you can simply go to advanced settings, and you can see all the parameters that you want to set. If in case of application server crash, in case of high response times of your application, some of the transactions, if they're taking too much of time to get the response, then you can go ahead and check all these values in order to achieve some of the values that are mentioned in the SLAs. It's not that you have to change everything. As process of optimizing the performance of any application, you need to work with connection pools, you need to work with application pools, you need to monitor different things from the application server, database server, and web server, and from the client side, server side, network side, all these things will happen. Now my question is, you can monitor all these things when you have a monitoring tool, right? A typical monitoring tool would configure with a big list of metrics, and it's going to give you all the information, right? If you're going to any IaaS server, if you go into Kubernetes, it is going to give you the problematic parts, problematic containers, namespaces. It's going to give you the entire information. Okay, I'm not sure if that is open. I'll still show it to you. Okay, so if you can see one of this thing, the monitoring tool, right? If you have a monitoring tool installed, the monitoring is so simple, right? If you go to server monitor, if you go to servers, right, how many of them are down, how many of them are critical, how many of them are these things. A simple thing is, if you go to Kubernetes, if you go to clusters, okay, if you have a monitoring tool, you can get the information like this. As simple as that. How many nodes you have, how many pods you have, how many of them are running, and how many services you have. And you can also see the problematic nodes, problematic pods, and problematic containers. This is one of my tool. So you can get the information like this. My question is, what if in case, if you really don't know what is that you have to monitor, if you don't have a monitoring tool in place, how is that you are going to monitor if your servers are deployed on Windows servers, if your servers are deployed on, if your servers are installed on Linux servers? So there is a way to identify. For example, we don't even know that many of us, not only me, many of us, we are not aware that we have a utility called Event Viewer, which is going to track down all the activities on Windows Server. This is my machine where its Windows Viewer is an utility. Okay, if you go to custom use, or if you go to Windows logs, then if you go to application, so if you're running a test, for example, I would filter this one. I would say I'll filter my current log, and I'm going to filter only warnings, uh, informational messages I don't need. I don't even want warning because it is not stopping my execution, or it is not failing my users from doing the activity. So if I click on this one, you can clearly see the errors that you got on this particular server. For example, let's say you imagine that we have WebLogic or WebSphere application server installed on this server machine. Okay, if you're running a test, when you see the error, application hang, if you double click on it, you have a first thing is you have a timestamp here, and you're going to get the type of the error message like application hang. When you double click on it, it is going to give you the complete information of the error that has happened. Okay, now you can see the log name is application hang, and the level is error. And you can also see the computer name, which is also the server name. And the timestamp is what you can see. If you're running a test from 12 o'clock to 1 o'clock, at 12:48, the error has taken place, which means that the application literally hanged at some point of time, and you have to find out the reason why. So likewise, uh, clear filter is what I have to click. Likewise, you also have perfmon utility, where you have lot of signs in perfmon. Again, perfmon is not like things, the way the things are going to work in perfmon are quite different. It's not like the way you imagine. Perfmon also has got lot of things. I mean, you can create a data collector set. When you can also pull a report. When you pull a report, a report looks like this. If you go to IAS, I think, okay. If you see the IO report, the report looks like this. If you want to change the way of the report, if you want to see, you can also see the report like this. You can take the report like this. You can create a data collector set. If you want to capture the utilizations on that specific server, you can create a data collector set using perfmon, and you can select a big list of metrics, and you can pull a report like this. And you can also get the detailed information to understand the behavioral pattern of that particular server when your test is being executed with some X number of users with Y duration. Okay, so in a similar way, you have uh, different things actually. I mean, I would say you have um, different utilities. You also have on the Linux servers, you have different monitoring tools like vmstat, iostat. You also have nmon, and you have nmon analyzer, which is a free utility. When you take a report, you can bring that from Linux to from Windows machine to Linux, or from Linux to Windows machine, and you can import the nmon file in nmon analyzer, and you can um, prepare a visualized report for your stakeholders understanding to show them how the values have increased from time to time when the test is executed. Okay, so after completing these things, we are going to talk about Java performance engineering. If you take, if you understand today's world, millions of Java applications are still existing, be it legacy, be it emerging applications. Things have changed a bit. The versions of the JDK they are using there, they might be different. Still, many of the organizations they are using Java JDK 8, right, for their own development. Now they are somewhere some JDK 16, not really sure, but somewhere they are JDK 16, Java JDK 16 or something. So in JVM, this is where you have to learn, spend your time uh, mostly, just because you need to understand what is that JVM is doing. Okay, how the JVM is linking, loading, executing, compiling the code. Basically, the difference if you find between the services-based applications and product-based applications, most of the services-based applications, services-based companies, the applications that they are testing into BFSA or the legacy applications, they do the same testing with the existing scripts with minimal changes. They don't touch the source code. They have some cosmetic changes on top of that application every time as part of every release. And they are maintaining the same uh, response times across all the transactions when users are doing that, right? So, but whereas in the product, what happens is you need to worry about each and every component. If your response time is 3.5 seconds, how much time it is taking for compiling, how much time it is taking for linking, how much time it is taking for loading, how much time it is taking, how much time it is taking for executing, how much time it is taking for garbage collection, minor GC, major GC, full GC. So all these things will be taken into consideration. But in services-based applications, right, that depth investigation is not being done, just because if you are meeting 3 seconds of response time, where your SQL query in that from the database server is taking 1.4 seconds, you don't optimize it, because overall response times, if you consider, it is meeting 3 seconds response time. But that is not the way it is going to work in product based companies, because product is something which we are selling it to so many other vendors across different geographical locations. In that aspects, every component that is the reason for performance degradation. Every API, every phase of this cycle, JVM, you know, right, it's going to allocate memory, it is going to take time for GC, it is going to take time for JIT compilation, it is going to take time for class loader subsystem in linking, loading, initializing. So wherever it is going to spend its most of its time, they directly go there and they have to fine tune that area to optimize the best out of it. Okay, because the products compete each other, right? You have, if you, for example, if you take two products like Swiggy and Zomato, if user friendliness, the services, on time delivery, or most importantly, easily finding a restaurant that you want and placing an order, the payment being successful and getting the getting the product delivered is what actually makes something efficient, right? So in that aspects, when we are building a product, we compete with the market standards. We consider the existing products which are already available in the market, and we uh, try hard to optimize the performance. Uh, we we try very hard to achieve that numbers comparatively when you have other products in place. So in Java performance engineering, we are going to talk about different architectures, on-premise applications, cloud-based applications, and we're going to explain you about what is the role of stack memory, heap memory, what is the role of threads, what is the role of concurrency, multi-threading. We will have a detailed explanation about the heap memory, especially young generation, old generation, Perm Gentil, Java JDK 7, Metaspace from Java JDK 8. We're going to talk about each and every single point um, to make you understand what could be the possible bottlenecks that you can see when you do any flavor of performance testing, be it load testing, stress testing, endurance testing, spike testing, reliability, sustainability, availability. And we are also going to talk about many of the advanced concepts. We'll show you how to install a WebLogic server, Apache Tomcat server, how to set the heap memory, what is the amount of heap memory, how to set the right heap memory for your application that you're testing. There is a math for that. How to decide how much amount of heap memory is required, and you can also see the advanced. We have two things. One is basic to advanced. In the advanced thing, we are extensively talking about JVM performance problems, the fixes, solutions, and what are the metrics, key metrics that you have to monitor from across all the different JVMs. And coming to the code profiling part, when you have a Java application, if you have uh, some utilities, if you go to the Java, right? If you go here, program files, then if you go to Java, right? When you install Java, under the JDK bin folder, you have so many utilities. Okay, I would simply show you one thing. There are few jar files that are going to help you for replicating some issues. We are going to provide all of that. So it's a simple jar file that I'm trying to run. It's a simple application. When I say jar file, you can assume it as a simple application. When you do some activity here, okay. Uh, Again, if you go to command prompt, if you type JPS, right, it is going to list on all the Java process that are running. You can see the process ID and you can also see this one. If you type JPS-L, it is also going to tell you the process ID of the Java process that is running and where it is actually available. Okay. So if you see here, now, for example, if you want to use JVisual VM, if you go here, okay. So now you can see Java Visual VM is opening. Now, do you see the process ID with the running application that is actually there on my machine? Ensemble app is already running with the process ID 9408. You can identify the same thing here. When you type here, it has given 9408, right? So when you double click on this one, it is going to give you some information like this. Let me see what's happening to my machine. Give me a minute, please. My CPU is 100%. Okay, you can clearly see, you can also monitor the heap size, you can also see all these things, right? You can see threads behavior, you can pick, you can also take sampling, you can do profiling from here. You can, if you see the visual GC, right? This is simple thing. So like I said, what is the compilation time? What is the class loader time? What is the GC time? When you see the memory spaces, you can also see the young generation, old generation meta space. So in the survivor spaces, you can also see the multiple survivor space and hidden space in young generation. So you can also take thread dumps and heap dumps as simple as that. If you click on heap dump, the heap dump is taken here. You can see the heap dump. Right click on it, you can save it. You can also take thread dump from here. You can simply click on thread dump. The thread dump is taken. You can save as and you can do that. So you can also forcefully run your GC from here. Again, Visual GC is a plugin. Likewise, there are many other tools like you have JProfiler, you have App Perfect Profiler, you have what? You have JConsole, JVisual, VM, you have Java Mission Control, you have Java Flight Recorder, App Perfect Profiler, YourKit Java Profiler. So all these profilers, we are going to profile the original source code to show you what are all the performance bottlenecks that you can see and what are the types of recommendations and suggestions you can make to the customers. Okay, and most important concept from the JVM side is understanding the heap memory structures, how the memory is allocated, understanding the types of references, understanding object allocation rate, object creation rate, okay, excessive memory allocation, excessive memory usage, understanding threads, how to collect heap dumps, how to collect thread dumps, okay. So you can also simply see a JProfiler, right? You can see we are also giving all these setup tools to you to see you also have some demo servers installed. When you click on this, we are going to give you all the we are going to give you the set of softwares that are required for your own hands-on practice. And if you see here, you're going to get all the information. Uh, with the demo servers, you can simulate the number of requests. You can simulate the number of JDBC jobs. You can also simulate JMS message handling. Then you can see the rate of activity that is being done. When you increase the requests here, you're going to get high memory allocation. So you can do some different activities. If you see the memory keeps on increasing, the reason why is because you are simulating more and more number of requests from a dummy server. You can also get some very good hands-on experience using the demo servers. Anyhow, we are not using demo servers. Demo servers is your for own learning, but we'll get it with demo servers. And what are the applications that we are deploying? We are going to test. We are going to run a minimal test on that to see how things are working under load, under different anticipated load conditions. So it's all about how you want to exercise your application. You can take a heap dump from here, then you can select all the types of references, what are the references that you want. So all these things, they are taken care right from everything. Okay, now taking the heap dump, then biggest objects, how much time it is taking. If you want to run an inspections on duplicate objects, you can click on this and you can get all the information like this. Then you can take a snapshot of this one. So likewise, we're going to talk about majority of the tools that are available. And finally, we are going to talk about the performance problems, GC types, GC algorithms, GC logs, how to analyze them, what are the things that you need to monitor in GC, how to analyze the GC, because as all of you know, the majority of the bottlenecks that you see from the application server are out of memory and memory leaks. There are simple questions that I ask from the interviews, like what is the main difference between out of memory and memory leak? Okay, I know that many of you are still preparing the entry questions, but that doesn't help when you cross your experience more than 5 years. If you take the market trends into consideration, whatever the traditional performance testing that you are actually doing, that doesn't make sense, because we are not testing with the real data. We are not testing on the same size of environments. Simple example. If you take your two database servers, which you already have in production, and the environment where you're testing, you're getting 80% of the utilization on the production database server, whereas you're getting only 15 to 25% of the utilizations, CPU utilization on database server in your testing environment. Can you tell me the reason why? Because no backups are running, no recoveries are running, no batch jobs are running. You don't have real time of data, volume of data. The size of the database server is completely different from what you actually have in prod. So there are a lot of things like that. That is called the gap between the performance testing environment and production environment. Whenever we want to test anything in specific, we're going to talk about the environment where we are requesting many of the stakeholders. We would like to have the environment which is same as prod, which is a mirror image of prod, right? Which is the replica of prod, which is called prod like environment. That's the word. So out of memory errors, memory leaks are something that you always see from the memory side. From the that's the reason you have to take multiple heap dumps to understand what is the memory allocation, biggest objects, how they are allocated, how the memory is efficiently allocated, what are the things that are happening. When you do, the reason why you have to take multiple thread dumps is because when you have resource contention, when two or more threads fighting for the same resource, that's called resource contention. Deadlock is something. You can also get a question like this: what is the difference between resource contention and deadlock? When you have a deadlock, you have to take a thread them to see which thread is waiting, which thread is blocked, which thread is continuously running, which thread is sleeping, which thread is parking, which thread has obtained a lock on object and it is not releasing. In that cases, you are going to see a deadlock. And again, when I say a deadlock, deadlocks do happen from the application server and database server. When someone is asking you, do you have any experience in identifying deadlocks? The immediate question from your side should be, which server are you referring to? Because deadlocks they happen on application server and as well as database server. Okay, so there is a different way to identify deadlocks on database server. We're going to talk about that. So we are going to talk again on GC logs. The main reason why we spend most of the time on GC is because if you talk about the primary most happening bottlenecks in any of the Java application, right? It's high GC pass time, more number of stop the world events are happening, which means for whatever the amount of time the GC is happening, the application will literally halt, will literally freeze for the amount of time where the GC is running. All the executing threads will get suspended for whatever the time the GC is running. So this is called GC pause time or stop the world event. In order to optimize the stop the world event, we need to find out the minimum time, average time, and maximum pause time for all the GC IDs. There are three types of GCs that are going to happen on any application when you're doing a load testing, performance testing, any flavor of performance testing. The minor GC, which is going to happen on young generation, the major GC, which is going to happen on old generation, and the full GC that is going to happen on across all the memory areas. So minor GC, major GC, full GC, all the different types of GCs that are running, how much time they are taking, what is the minimum pause time, what is the maximum pause time, and what is the average pause time that they are actually taking. To find out that, we have to take multiple GC logs, and there is a way to analyze GC logs to find out what is the reason for performance degradation with the GCs that are running, the rate of GCs, the frequency of GC that is happening. Okay, so there are so many scenarios. If your memory, if your heap memory is so small, the more number of times the GC is happening. If you have an undersized memory structure for your heap memory on your application server, if your memory is so small, the more number of times the GC is going to happen. I'm not talking about the overall memory. Even if you have an undersized young generation or undersized old generation, the more number of times the GC is going to happen. When the more number of times the GC is going to happen, the more number of times the application has to stop, resulting high response times of that particular transaction. So for that reason, you have to take the help of GC logs to find out which GC is the reason for all these bottlenecks that are happening. Okay, so these are all the things that you basically understand. I mean, memory leaks. We are also going to analyze from here. Okay, so do not worry about lot of things that I'm showing, but all these things are part of our program, and we are going to tell you, we are going to analyze heap dumps with 7 to 8 tools that are available in the market. We are going to analyze 9 to 10 tools, thread dumps, heap dumps. We're going to talk all about that. We'll also tell you how to integrate your source code with the profiling tool. Example, it's a memory leak a sample program. When I profile this as Java application, all this source code is getting profiled where? Is getting profiled. What did I do? See, JProfiler has automatically opened. The reason is I have integrated JProfiler with my source code. So there is something called, if you see, there is something called shift left performance testing, early performance testing. So if you go back and recollect your past from your experience, there is a most frequently asked question: when is the best time to do performance testing? The straightforward answer is whenever the application is functionally stable. Okay, that has been that. I don't say that it is getting unfollowed, but with the recent emerging tech stack, emerging trends of performance, there is nothing like that. Whenever a service is developed, whenever an API is developed, whenever a page is developed, okay, so whenever a piece of code is developed, the performance, they are starting performance testing in parallel with development, which is called early performance testing. When you have a service ready, when you have an API ready, they test with 5 users, 10 users, 25 users, and 50 users to eliminate the bottlenecks at the very early stages of the development, so that it is not going to create too many bottlenecks when you integrate all other components as a system. That is where you don't find some of the transactions taking 29 seconds, 30 seconds of response times, because as part of early performance testing from the development itself, they are optimizing most of the performance. 70% of the optimization is being done because the performance engineers with developers collaboratively, they are optimizing the code as part of code profiling. They are identifying the hotspots, they're identifying the hot methods or functions. Example, functions taking too much of resource consumption, like one function called once or multiple functions called together can be the reason for consumption of 80% of the CPU utilization. So one simple service can consume all your memory by 45%. So they are finding out all the bottlenecks in process of early performance testing, shift left performance testing. Eliminating the bottlenecks at the development stages is actually saving a lot of time and optimizing the performance to a greater extent in the initial stages of development and performance testing. So we are also going to talk about a little bit of microservices there, how monolithic environments are different from microservices, why many of the companies or applications are switching from monolithic to microservices is what we are going to talk, and the strategy, the approach, the process, as many of the students have requested. We're going to take 1 or 2 sessions on how we have to do performance testing on microservices applications. Okay, we are going to highlight that, which is not added here. And real-time issues is what we are obviously talking here, how to uh, identify different bottlenecks from client side and server side. And when I say server side, we are being specific here. I keep telling the same statement again and again. Most of the applications, if you see, 20% of the bottlenecks, they do happen from the web server. 25 to 30% of the bottlenecks, they tend to happen from the application server. And all the 45 to 50% of the bottlenecks, they're directly from the database server. So it is important when you gather NFR, when you're a part of NFR, even if I from the recent last 1-2 years, to the teams that I'm meeting, to the teams, customer facing groups that I'm talking, what I understood is there is a no concept of centralized teams. Very rarely you have in the service-based companies, like very big accounts like Lloyd's, JPMC, then BFSI domains, they do have centralized teams working together on scripting, execution, and analysis. But many of the assignments and organizations, doesn't matter how many years of experience you have, one performance engineer will be allocated to take care of the application performance, right from the non-functional requirement gathering till the sign-off. Be it 1 year, 3 years, 5 years, 10 years. Even a 12 years associate has to do advanced scripting, correlation, then integrations, creating dashboards, creating a CI/CD pipelines. All these things have come into picture, into limelight. So you have to prepare yourself in a way that you are a part of everything. I mean, every individual phase of performance testing life cycle, NFA gathering, workload model creation, capacity planning, understanding the environments, creating a performance testing environment right from the scratch, selecting the right tool for your business needs, for your various business demands. So all these things you have to identify. You also need to clearly identify the performance goals. Example, few applications, they target to optimize only the network performance. Okay, if you identify what is that you have to achieve as part of that particular assignment, sometimes in some of the cases, tools like Dynatrace, CAAPM, New Relic, AppD doesn't help much when you are evaluating the network performance. If you want to extensively monitor network, there are other tools like SolarWinds Network Performance Monitor, where it is going to get the detailed information of the routers performance, switches performance, devices performance. It is also going to tell you time spent on the wire, time on the wire, the signal transmission. I mean, the signal traversal rate from, if you are sending a request from Kanyakumari to Srinagar, which is 3,006 kilometers approximately, for every 1,000 kilometers, there is a value that it has to take for traversing the signal from here to here as part of sending the request. When you get the response, when you send the request, it is going to have a time on the network. So there are various parameters that you need to find out, and that can be achieved only with a dedicated performance monitoring tool like SolarWinds Network Performance Monitor. It's an extensive network monitoring tool which is going to monitor everything from the network. So the first thing is you need to identify what is that you have to achieve, performance goals. What is the role? What is your role? What are the things that you have in place? From the existing things that you have in place, what are the additional things that you need to derive from that? Okay, how you need to create a strategy, how you need to create an estimation, how you need to create an approach, how you need to mitigate in case of any issues, downtimes on sensitive applications. All these things should be a part of a performance engineer day-to-day job, right? Performance tester is not actually a performance engineer. Performance tester is actually who is going to script. He puts his script into some execution engine, PC, LRE, Blaze Meter, Storm Runner, Cloud. You run it with some number of users, correct the load generators, take a report. No, it's not the actual performance testing. Performance engineering, many of us say that why I should learn performance engineering. You need to find out various problems at various places, be it internal component, external component, be it server, network, load balancer, firewall, anything from it's the job of a performance engineer to monitor every single place of your environment to find out the hard hidden bottlenecks. And it's the job of the job of performance engineer is to meet the SLAs as per the business requirements. Okay, so the same way we are talking about, I told you, right, we are covering all these things. Okay, and also performance testing best practices we're going to talk about from the documentation side and all. And the similar way, like .NET, like JVM in Java, we have CLR in .NET. For Python, you have PVM. Okay, likewise, you have different things. So in .NET also, we are going to do the same thing. We are going to have heap memory analysis. We are going to have threads concepts. We are going to have GC types, .NET memory management. What are all the problems that you're going to see from different areas is what we are going to tell you from the .NET applications. Okay, so the last one is I'm sorry. We will primarily focus on three databases. Uh, Example, if you can see here, this is one thing that we currently, I think I uninstalled that, but here what you can do is we're going to talk about Oracle database. We're going to teach you how you have an Oracle database here. Just a minute. So if you want to extensively monitor your Oracle database server, you have an Oracle Enterprise Manager, which is an utility of Oracle database server. This is where you can get information like this. Okay. So the information of the SQL queries, then resource utilizations, active sessions, the memory, I mean, the split of memory areas is what you can see here. And you can see the services, you can see the containers, and you can also see there is a something called performance hub. If you go here, it is going to give you, if you're running a test from 655 to 750, you can drag and drop here, and you can get the information. For example, I want to see the utilizations from 715 to 740. Okay, if you want to get the data, you're going to get the data like this. Okay, you can click on show total activity. You're going to get all the information like this. So if you don't want to do like that, you can put the complete timeline here to see what values you're seeing. But for now, there is no data. It's a sample SQL ID. If you're clicking on one of the SQL ID, right, it is going to give you the complete SQL execution plan. I mean, I would say the activity, it's going to tell you the execution statistics, what you have in a SQL query. It's a simple data. Okay, so we are explaining about Oracle database. We are explaining AWR report, ESH report, and we are also explaining about ADDM reports. And The last one would be the client-side performance testing. We're going to talk about GT metrics. We're going to talk about Google Lighthouse, web-based test. We're going to talk about Firebug, Wiselo plugins to find out what are all the bottlenecks that you see from the client side. If you see many of the applications now, right? Many of the applications they're using emerging tech stack uh, like HTML, CSS, JavaScript, React JS. So if you want to know what are the JS calls that are taking so much of time, what are the CSS calls that are taking so much of time. So all these things, if you want to see that, you have to do client-side performance testing, and client-side performance testing is being done only with one user. Okay. So we are going to talk about how to optimize client-side performance, and there are few terminologies that you have to find out what is the role of a CDN, okay? What is the role of DNS? What is a DNS query? What is the role of a firewall? And what does a load balancer do? Okay, and coming to the cloud, how cloud-based performance testing is different from the performance testing that we do on on-premise applications. So all these things will be taken care line by line. And if you see here, this is the pattern that we follow. I think I am not sure how many of you know. If you see the batch 8, this is the pattern we follow. If you every session is going to contain information like this. Every session you can see something like this: introduction to performance testing and engineering concepts, understanding the performance SLEs, the common performance problems, and NFR gathering. So every session would have something like that, and you're also going to get uh, something like this, like entry questions from the right from the scratch, uh, making you understand the difference between a hit, request, or page load time, response time. Any of the questions, if you don't get a chance to find out the answer, we're always there to help you. And we also have a documentation like this, common perform, whatever we teach, we're going to give you the clear cut material on which you can stay on to read that in the way you're comfortable with. And in the end of the session, we are also helping you the way you have to put things in your resume to find a right job. And someone who is serious about looking for a switch can opt this course, and yeah, we can do customize, take up some additional sessions if in case if you need anything else. Okay, I mean I would say anything that is required for you or that is helping you from your personal assignment. We are always there to help you, and the timings are from 7 a.m. to 8 a.m. Preferably, I would start 6:45 a.m. as well, because many of you has to drop kids at school and have to go to offices. So once we get all the confirmations, we're going to start the session at 6:45 and we'll wind up at 8. So that's all about today's session, and thanks a lot for joining. Thank you so
Okay.
much.